isotope name or isotope notation, which was your name and then the mass number, right? And then if we think back, we know that atomic number is always equal to your protons, is usually equal to your electrons. So for the most part, you guys can guarantee that those three columns on a table is going to be the same thing, right? Okay. Then your mass number is equal to your protons plus your neutrons. Sorry about that. Did not mean for that to be in the middle of the screen. There you go. Is your protons plus your neutrons, right? And so you can figure out neutrons by subtracting the atomic number or the protons, any of those. So you have that already. So when we go to use this for the tables, okay, you're able to figure out a lot of these things, okay? So you do have your two definitions up here. So what is an isotope? We've got that. We have what is an ion. So remember, an ion is going to be the thing where you have different number of electrons from protons, right? So you do not have protons equal to your electrons. You guys, I need you to just be able to recognize that, which you had a question like that on your quiz just a second ago, okay? So when they were different numbers, that was where you had that. So actually on that note, let's just go ahead and let's fast forward to this middle part. Because this one we talked about, and then I've put it on this quiz, and I've asked you again, right? So let's just make sure that we understand this. So this is exactly the same thing that you guys just had. So looking here, it says which samples represent the same element. So what are you gonna rely on to figure that one out? You have protons, neutrons, and electrons. The protons and electrons, and I'm gonna take it one step further and just say, what is the always guarantee? Just the protons, right? So looking at our list of protons, which two were the same? Which samples? 1 and 2, right? Because we had 55, 55. Who is that on your periodic table? You could look it up if you really wanted to. 55 is cesium, okay? So both of these are cesium. The other ones you could figure out by looking up their atomic number, right? So sample 1 and 2, okay, because we focused in on the number of protons. So protons were the same. What is the mass number of sample 1? So we have our sample 1 right here, okay. How do I get my mass number? I just showed you guys that. Mass number is equal to what? Protons plus neutrons. Good. Protons plus neutrons. So let's look up here. We have 55 plus the neutrons, 78. So we have 55 plus 78, and that'll equal 133. So the mass number for sample 1 is 133. So since we just talked about it 2 seconds ago, let's go ahead and write the isotope notation for that, okay? So the isotope notation for this guy is going to be, we said cesium, and what do we put after it? For sample 1, cesium what? How do we write isotope notation? It's your name and then a mass number, right? Name and mass number. All right, so I wrote cesium. That was the name. What am I going to put here? What did we just solve for in letter B, you guys? Well, the mass number. Isn't that the part that should go there? So it should be 133. Okay, so 133. So we have cesium 133. That's that isotope. Just quick question, just to make sure we got it. What is number 2's name? Number 2 is cesium. And then we have 2 less neutrons. 131. Good. Okay, so those are the isotope notations. Those are the isotope names, okay? All right, And then finally, letter C said, which sample is electrically charged? Which one is that one going to be? Sample 3. And that's because protons are not equal to your electrons.